So I mentioned the other day on Twitter that I was going to do, I suppose, a basic run through of some simple functions within R. So we're just going to look at how you can load and carry out some initial exploration of the data, some kind of mutate, so creating newer columns based off old ones, so how you can summarize the data into daily or weekly or even monthly if you want to go that far. Basic filters, so within this data set it's going to be filtering by players, by most recent data or even today's data. We're going to look at carrying out some further mutates where we'll create what percentage of kind of a metric somebody has done based off max values, and then some rolling sums, rolling averages, things like that. And then we're going to look at z-scores quickly at the end, and within that as well I'll fit in some way how you can join data sets together. So the data we're going to use, it's just some, I think it's about a season's worth of GPS data. So it is, yeah, so it's about just over 12,000 rows, so a season. I filtered out, so I just kept in a handful of metrics, so one's around the total distance, velocity, and then the distance covered in the different velocity zones, just for the player name and the training session name. I've just de-identified them with a package in R and Anonymizer, and yeah, that's everything there. So let's just load up. So first things first, we just need to bring in some packages. So most of this I'll do through the tidyverse group of packages, and then for the rolling functions later on I'm just going to bring in zoo as well. And I'm also going to load in a package called tidylog. So tidylog will just bring up a bit of a bigger indication of what I've done within the piping function when you see it occur. Speaking of which, I might give it as well. So let's load in the data. So data frame, let's just call it GPS data. I'm going to use read underscore CSV from the reader package. I have this set up in, or RStudio set up in a project environment at the moment, which means all I need to do is reference this data frame or this CSV down here rather than put in the full file path. So all I have to do is sample GPS data.csv, and that's loaded in there now, and we can just do a quick look at it. So now you can get a rough idea of what the data is loaded in looking like. So you can see here, again, the same columns that we had in the Excel sheet earlier. Just a couple of things to kind of look at here. So you can see, let's say season is loaded in as a numeric value. Although in this data set there's only one season, if we had a data set with more than one, ideally you'd want to change that to a factor. So we can have a look how to do that. Then you have player name and character, again with the random gibberish. The date is loaded in the character, so we need to change that to a date time. Field time we'll leave alone for the time being because we won't really use it this time around. And then everything else is loaded in as numeric. So I looked at it here, this time using Glimpse. You could also do View, which will open it up in a separate viewer. And you get to just look at a bit more of the data. Obviously with the larger the file size, the longer it takes to look at something through View. You also have a separate option of STR. But again, I find this to be a bit of a messy way of looking at it and doesn't quite make it as intuitive as the other two to figure out what you want to see in it. So we could also do something along the lines of, if we had a so let's say if you wanted to see how many individual training days were present in it, you could look at the unique number of values in the date one, and you see here, so it's 293 training days, which again is about similar enough to a season. If you want to see how many players are present in it, you can just do this. Alright, so there's 55 different players and anything along those lines. So now we can just go down here. So I'm going to start using this piping function So piping function, the easiest way of, I suppose, understanding it is it's as simpler as, or it's the same as saying then, which will make sense now in a second. So first of all, we just need to make those changes that I mentioned earlier. So season will change to factor of season. If it was a case where you had different seasons, you could easily put a levels in here, and let's say that would be, you know, 18, 19, then 17, 18, etc. It isn't the situation here where we've only one season data present. Then date, we want to change to a date time variable. So I'm going to use the lubridate package here. Actually, if I just run glimpse here again. Now you can see here the date in this dataset is in the day, month, year format. That makes changing it a bit easier it makes changing it with lubridate quite easy because we have a day, month, year function here, and we just need to wrap it around that. So now I can just run that into a glimpse and make sure that's making the changes I want to do. So now we can just compare between them. So season has changed to factor and date time has changed to date, which is what we wanted. So now I can just remove this. Actually, I'll make it as a separate data set. So if I go GPS data 2, then if I go down here, view, GPS data 2, and then it pops up here. Separate data set with those changes that we spoke about mentioned. Now, we can also carry out some changes to create newer columns. So in this data set, we might want to do something like, let's say, rather than having these 7 different speed zones, group them together into a high speed and maybe moderate speed one. So if we create a moderate speed distance, and this is just going to be a simple plus sign between them. And then high speed distance, or high speed distance 5, 6, 7, and let's just run that into a glimpse first. Oh, the pipe. And you can see these pop up at the end here. Now we have the option where we can get rid of, or we can choose which ones we want to retain. So we can use select in here, comma, and now which ones do we want to keep. So because we have only one season, we can get rid of that. Player name we can keep. Let's say we'll keep period name for now. Date we can keep, so it's 4. Field time, let's just remove that for this instance, 5, 6, 7, and then, so the rest we want to get, if we go 15 and 16 then. Just close that. Do it here. Yeah, so now we only have the 7 columns that we want to keep for the rest of the session. Now within this, we can also actually make this a bit shorter as well. So if we wrap that up, so let's say we can group 2 and 4, and there isn't really much we can do with the rest of them, but 2 and 4, and you end up in the same result. So now if we remove this glimpse and just take a look, this is the data set we have. So we can also do something, so I created these using a package called Anonymizer, which essentially looks at any unique value and assigns it a random string value. Obviously I don't need it to be quite as long as this. So what I could actually do is we go in here, we go player name, and we can use the sub-str function. So it's going to be player name in here again. So now what I'm going to do here is I'm going to say I want to start at the first character, finish at the 5th, and we'll take the first 5 values of the string. Knock that back there. If we just change this to period, this to period, and just to show again. So now rather than the quite long strings that we had up here, we just have the first 5 characters of them. So it's a bit easier to use then when we go into something like view down here. It's just a tidier way of doing it. Obviously, if you have thousands or tens of thousands of unique values in these, when you try to anonymize it, you need to be careful about trying to cut it down like that, because it may end up with separate values being coded as the same. So obviously within this data set, or within any GPS data set like this, it's always worth having a look to see if there's been any instances where players have had 2 sessions in the same day. So we can use that if we go group by, and we'll group it by by date, and then we'll look at player name. Now we're going to use the count function, and straight away we can just have a quick look at this data, show you what it's after doing. So now it's just put in a count of how many times each individual has occurred within a date. Now obviously we don't want to be in a position where we could just run this into view. We go, take a look at it this way, click up here, and you can sort it. And you can see, alright, so there's up to, for some reason, 8 sessions in a single day, which doesn't quite sound right, but we'll leave it alone for now. We also have the option of carrying out that same function in here using arrange. We'll go descending. So as you can see here, the count creates this n variable, so we'll arrange descending by n. Then we can just pipe that into glimpse. And now it automatically sorts it where highest at the top, lowest at the bottom. So straight away we can see that we need to carry out some kind of summarizing data or summarizing function on the data, so that for each day everybody only has a single value. And we can do that using the summarize function, where we're going to again group by date and player name. And now so summarize will look at it and it will return a function, or return a value based on the function we tell it to do. So let's say for, what does we have left? So yeah, so if we just carry this odometer, actually we call this total distance, is going to be equal to the sum of odometer, excuse me, and what velocity they reach is going to be the max velocity, and so on. But in this, it's not too bad in this data set where we only have 4 or 5 variables to work on. But if, let's say, we were looking at a full data set where you might have 30, 40 plus, this could be quite a repetitive way of doing it. So we do have the option of using a range of summarize functions. So we have summarize all, at, each, or if. In this instance, we're going to use summarize if, and we're going to say for is numeric, and then we will run functions into it. And let's say we want to do mean and max, and we just have a look at this now. Oh, should be capital D. So now it you can see here now that it has, anyway, so you can see here now that it's carried out the mean and max function on each of the different variables we asked it to. In this instance, we obviously we want to look at that should be sum, not mean, sorry. The sum and max of the different variables. So in this instance, it's done something wrong. There we go. Don't know why it didn't work the last time. So it's got the sum of, let's say, odometer, moderate and high speed distance, and we want to keep the max of max velocity. So similar to before, we can run this into a select, We want to keep 1, 2, 3. So let's go start the list. So 1 to 3. We don't want 4. And then we want to keep 5 and 6. And then it's going to be 8 is the next. But if we throw 8 back here, then we have max velocity where we want it. I'll just pipe that into a glimpse. Oh, I need to close it. There we go. So now we have all the values in the correct way that we want them and in the right order. So if we go back up here and just turn this into GPS daily, move this out here, and then let's just take a look at the data frame we just created. So now we have a single value for total distance, max velocity, moderate and high speed distance for each day for each individual. Maybe moving on from that, it may be a case that you want to produce weekly values. So rather than repeat, let's just go down here, put in weekly. We can copy that in here. We're just going to change GPS weekly. We do need one step in between though, where we actually need to give it a week value to use as a reference, which we don't have at the moment. Again, we can use lubridate for this, which has a week function. We're going to apply that to date. And just to show you, you can just put a quick glimpse in here. And it's just created an additional column called week. So we can just remove this out. So now rather than grouping by date here, we can change this to week. And then if we run this, and just change this to, yeah, okay, so we've got some NAs popping up here. That's probably due I left out a command, but just an example. So you can see here NAs have popped up for max velocity values. That will occur because when you have, let's say, across a training season, you're going to end up with sometimes where for whatever reason, maybe you're modeling data or it's from international teams or other training teams, they're on loan, things like that, and you mightn't get full values for anything. So let's say if you're missing something like max velocity, or we'll read that as an NA, if there's an NA value present in a data set, that's going to get assigned the max. So if we go here and just take a look at GPS data max velocity, it just returns an NA, even though the highest value from our perspective wouldn't be NA. But when we're summarizing the data, which I should have done up here as well, we have the option of an NARM equal to true, and that will stop it carrying forward those NA or missing values when we're summarizing the data. So if I go into view, before I run this, if I look at GPS daily, is there any NAs here? So there's no NAs here at the moment anyway, but it looks at it. Oh, wait. Yeah, so we have some popping up here now. If I go back here, and hopefully this actually works. True. Oh, I put it in the wrong place. And now if we take a look, see, can I bring up any NA values? Also, there's some coming up in date. These have changed to INF. But the NAs themselves have disappeared. So we just need to do the same down here as well, na.rm equal to true. So I can just use capital T as well for true rather than typing it all out. If we take a look, yeah, so there's no NAs now in max velocity. Now we can actually view what those highest values are. We could also do, let's say in this one where if we go and look at GPS daily, and the INF values have occurred here, we could continue this on into another mutate. So that was in the So max velocity, yeah. So if we go max, it's going to pop up. So is it max velocity underscore max? Is that what it was called? Max velocity underscore max, yeah. Is equal to, now we can use a function called case when, which is really similar to an if function in Excel. If we do case when, actually if we wrap this, is dot infinite. So that's what the INF value is saying, it's an infinite value. Is dot infinite. We'll change that to zeros. And then we'll leave everything else alone for now. Again, this is true. Yeah, everything is closing. And you see even down here, it changed 3% of the max velocity values to zeros instead of NAs. This never works first time for me. There we go. So now we have a lot more zeros rather than the INFs we had previously. Now with this is infinite, you have a range of choices here. So you have, if we go, so you have is infinite, NA values or NaN tend to be the ones that come up. And you can simply wrap, using case when, wrap it in this. So what this is doing here, this will return a logic or a logical value of true or false for this max velocity column,